Hello everyone. So I'm just gonna quickly go through the answers for the Year 12 Mathematical Methods Worksheet 4. Alright, let's start. So question 1. And as you guys see, I have all my working out listed, but I'll quickly just go through like my thought process of how I work through each question. Anyway, so first one, we have y equals cosine x and y equals sine x. And when immediately we see intersection point, we just know they have the same x and y values. Therefore, we can just equal the two graphs together. And since the point is at x equals to pi on 6, we can sub in x as pi on 6. So we get this equation here. And when we solve it, we just get a equals to root 3. And the next question, we have to find the other intersection point of these two graphs. So again, we copy this equation down here, but we sub a equals to root 3 because we already worked it out above. And we rearrange it to get 1 on root 3 equals to 10x. And we know 10x is positive in the first and third quadrant. And since x equals to pi on 6 is the solution in the first quadrant, the question is just looking for the solution in the third quadrant. And that is 7 pi on 6. Alright, question 2. So find the rule and domain of G inverse of x. So therefore, usually when we do inverse functions, we just swap x and y around. And I didn't have like much space here. I only wrote down the answer, but I can quickly do it here. So we just swap x and y around for this equation. So we do g of x minus 1 on 2, and then we raise it to the power of e, and then we minus 4 is equal to x, and then we swap g of x and x, so we get x minus 1 on 2, e to the power of all this, minus 4 equals to g of x. Well, g inverse of x, sorry, because we're taking the inverse. So that's how I got this here as that answer. Alright, so I'll quickly erase this. Alright, and don't forget, a really common mistake for people with these questions is that they didn't read the full question and forgot to work out the domain. And this is usually a really easy mark because the domain of g inverse of x is just equal to the range of g of x. So domain of g inverse is equal to range of g. So as we can see, g, which is the black line here, its range is infinite because this will go infinitely up, right? So therefore the domain of g inverse is real as well, because the range of g is real. Alright, and then we're sketching these. Now we're going to sketch g inverse of x. Usually for these type of questions, my first step is to work out the asymptote. So by looking at this graph here, we know there's a asymptote y equals negative 4, and we can confirm this by looking at the actual like g of x, that it has a asymptote at x equals to negative 4. Therefore, for its inverse, it will have to have an asymptote at y equals negative 4, because they're the inverse of each other. And then what I did is I worked out the coordinates of the two axis intercepts. So the first one is 0, e to the power of negative half minus 4. And to do this, we can just let, and for the y and x intercept, we just let y or x respectively equal to 0, and then we can work out the two coordinates. So after plotting these two coordinates, I just connected them through a graph like this. And keep in mind, try to imagine there is a y equals x line like for this part here. Notice how I like kind of dotted it out, because for when two inverse graphs intersect, they will always intersect at y equals to x. So as we can see here, there's two intersection point, and that is exactly what the next question asks us to do, which is to solve for values of x, and which is these 2 points. So to work out this question, we just define g of x on our CAS and g inverse of x on our CAS as well, and we let them equal to each other, and we solve for x, and we'll get those two solutions. So this is a CAS question. And the next question is that calculate the area enclosed by g and g inverse of x, and then give your answer to the decimal places. So to get so basically what the area this question is asking for is, well, this area bounded here. And to work out these area, we just, because since we know the coordinates of these two intersection points, all we have to do is take the integral of these 2 points for the top function, in this case g of x, minus the integral of the bottom function, which is g inverse of x. and which is exactly what you guys see here. Actually, I made a mistake here, and in exams, if you guys don't write this, it's actually quite possible that examiners will take marks off, which is the dx at the end here. So yeah, make sure we add that to the end of every integral. And after evaluating that, we just get 52.63. And that's another important thing. Make sure you add units at the end of every question that asks for either area or volume. So in this case, if it's area, we add units squared. And if, like, for example, it's another question that's volume, we just write units cubed. So that's quite important. And yeah, those are all really like marks that a lot of people happens to miss, basically. All right, question B. So the first part of this question is to state the value of a, and this is quite straightforward because since the graph has a asymptote at x equals -1, therefore a has to be 1 to make it like log e x plus 1, and that will create this asymptote basically. And now we have to find the value of c, and c is the so c is the vertical translation, and this graph tells us that we have a y-intercept at 0, 1, indicating that this graph goes to the point 0 and 1. And since we already know a is 1, we just sub x equals to 0, and we get something like this. And notice how since x equals to 0 and a equals 1, log e of 1 is just equal to 0. So this whole thing here equals to 0. And since we know f of 0 equals to 1, therefore c has to be 1. And that's why the value of c is 1. And then next part is we have to show that k is equal to this. So again, we can first write out the equation like what we got by subbing a and c, and this is what we got from here. And the graph tells us that we go through the point p and 10, so we can sub that in. So we get 10 equals to k of log ep plus 1, like that. Rearrange a bit, and we'll get to our final answer. And the next question is we have to show that the gradient of the tangent at point P is to this. So immediately when we see gradient for any methods questions, we will immediately think of derivative. So, because k is a big value, I decided not to sub in right now, and we can like sub in at the end, so we can save space. So we have f of x is equal to all this, and the derivative of that is equal to k on x plus 1, so that's a derivative. And now we can sub k as what we worked out before, which is 9 divided by log e of p plus 1, and we get this. And notice how the only difference between this line here and this line here is the x plus 1 and p plus 1, and all we have to do is change x to p because we're working out the gradient at point P, and that's why x is equal to p, and then we can get the gradient is equal to this. Alright, final question. If the point -1, 0 also lies on the tangent referred to this, all we have to do is find the exact value of p. So when the question gives us a point and we have another point given, we can use the gradient formula, which is this. So we can use gradient is equals to x1. Sorry, I meant y. Y is on the top, not x. So I'll quickly rewrite this. So we can get y2 minus y1 on x2 minus x1. This will give us the gradient. And notice on the question before, we also worked out the gradient is also equal to this. And then all we have to do is to solve f dash of p, which is this equation up here, is equal to this here, cas, and then we'll get p is equal to e to the power of 9 on 10 minus 1. Alright, and yep, that's everything. So hopefully this solution helped, and if you guys have any other questions, feel free to ask me in WeChat, or you guys can come to the study hub, which is 6:30 to 8:30 every Tuesday. Alright, cool.